Welcome to this video on disaster recovery strategies. In the previous video, we talked about disaster recovery planning in terms of the impact to your organization. Now we are gonna talk about some recovery strategies such as resilience, high availability, quality of services, and so on. Now, if you recall from the previous video, a disaster is an event that causes great damages or destruction of the property or loss of life. So either we can have damage to the facility, damage to our operating resources, or just destruction overall of our facility, property, things like that. Okay, and again, business continuity is focused on critical business function. Disaster recovery is focused on the asset that support those functions. So one of the way that we can ensure those business assets or those business functions stay up and running is to implement system resilience. This is the system's capability to recover from disruption. So if there are some kind of failure, some kind of outage, it will recover. It's designed to recover from that disruption. So it might be considered a compensating control. If we wanna go and route, so it will minimize all of the single point of failure to prevent a disruption of a critical business assets or function. So in other words, if a major website like Amazon.com was only running on a single server and that server were to experience a fault, Amazon.com would cease to be in business, right? They would be gone because everybody would target that one server. They would take the server down and now they can no longer function. That's why Amazon has region all throughout the world in which one server fails is just port over to another AMI, right? Another Amazon machine instance spin up and now it's up and running and the user will know no different. They will never see any failure. That's how they stay up and running. That's how they stay in the business. And that's exactly what we are talking about. There's also fault tolerance, which allow the system to continue operating during a failure. So if you have a fault or in failure in system, fault tolerance will allow the system to continue to operate. So it's kind of form of a system resilience, if you will. And then there's also high availability, which allow the system to continue operating without failure over a long period of time. So basically what we are doing with high availability is we are using redundant system. So we have redundant system, redundant server, redundant application, whatever it is, that makes sure that the system could quickly recover if a failure is experienced. Now both of these are form of system resilience. System resilience is kind of overarching term for it, kind of like in configuration management. Then you have change control and change management underneath. Some exact thing you have system resilience. One of those things is fault tolerance, and then the other is high availability. Fault tolerance is normally built into the system, normally has the feature built in, where high availability is redundant system. So you have more server, more networking devices, more firewalls, and so on. And then we connect them together via software, and then the software will perform that rollover or the cutover if something were to happen. So part of the disaster recovery strategy should be how we are going to build these things into the system. And they are really necessary. Do we need this in the system? And if we do, how are we going to plan on how we are implementing those? And one of the major consideration is your data protection, right? How the data is being protected while it's in storage, while it's in the rest, and if you need to recover it to continue operation. One of the way that we do that is we use RAID, redundant array of independent disk. This provides fault tolerance for hard disk drive. This will increase the performance and redundancy by using multiple hard drives to store information. The reason we do this is if one drive fails, the other will still maintain the data. They will still have the data on board, which is a form of fault tolerance. So we can configure this in a variety of ways depending on what we need. The first thing that we could do is a RAID 0. This is called striping, where we write the data to multiple disks but we do not have the fault tolerance. So basically we are dividing the data into blocks and then we are copying them multiple disks. What this helps do is balance the load of the overall disk storage. Then we have RAID 1, which is mirroring. This is where you have identical copies of data stored into two different disks. Now, this is obviously the most resilient and the most secure, but it is going to require the most resources because you need two different disks, right? And you are gonna need disk for every single drive that you are going to mirror. So if you wanna mirror 2 drives, you are gonna need 4 disks. If you wanna mirror 4 drives, then you are gonna need 8 disks, right? So you just double it. So again, it depends on how much storage you have and how much you want to invest in the storage technology. So now we have RAID 5. RAID 5 does striping with parity. This use 3 or more hard disk drive with one disk maintaining the parity information. Parity is basically a copy of data blocks. So if a drive fails, it can be restored from those parity blocks. So it's just a way of maintaining data integrity, if you will. Okay. The RAID will become slower if one of those disks fails. So the drawback here is one of the disk fails, you are gonna lose performance, but you are not going to lose your data. And then there's a RAID 10, which is stripe of mirrors. We are using 4 more disks to mirror the data and then write it to multiple drives. Okay, so we are doing combination of both. We are spreading the data out across all the disks, but we are also mirroring it at the same time. Those are the 4 you need to know for the exam. When it comes to the RAID, now the data is served up by the computer. That's called server, right? So we need a way to protect the server as well, to make sure the data can get the customer or get our personnel when they need it. One of the consideration is to use the failover cluster, is where you take 2 or more server or 2 or more nodes and you connect them so they work together to provide availability in event of a failure. That way, if one of the server or one of the node fails, the other 2 will pick up the slack, pick up the workload and continue performing business operation. So it's also a form of load balancing. So this is where you are distributing all of the different communication and all of the different processes between 2 or more computers. That increases the response time for some of these servers and so on. So it's just a way to help balance out the activities that's going on within that server cluster or just the server in general. You can also do that at a network level at all. You can install what's called load balancer that will do the work for you as well. Then we have to be concerned about how do we keep the power to all of these servers so they can provide all of the services for critical business functions. The 2 different ways that you need to know for the exam. One is UPS, uninterruptible power supply. This provides uninterrupted power for a short period of time. This is typically battery backup. There is also a form of this called flywheel. So nonetheless, they cannot operate for long period of time. Now, if your facility is located in an area where you can expect long period of outage, whether it be a man-made or even a natural disaster, a generator would be your best option. These are motor operated machine they will provide uninterrupted power for a long period of time. So generator are long period of time. UPS is basically battery or flywheel backup. That's provide a short period of time. Now, what are the drawback to this? For both of them, it's going to be storage space, right? You are going to need the space for them. One, for UPS, you will need the space inside of a data center or inside of a computer equipment room, or storage, or the battery packs, or the store of flywheel device, right? Whatever it is, what you are using. Typically it's batteries, so you are gonna need a place to store all these batteries, and sometimes there's a lot of them. I remember working in a couple of different environments where we had rows and rows of batteries, and I mean, it's insane how many batteries you might need. On the other hand, you have the generators. This requires a lot of maintenance. It's motor, right? It's a little engine, so it has to be maintained. It's gonna need fuel, whether it be gasoline, petrol, propane, diesel fuel, or whatever it is that it runs on. You are gonna need it. You are gonna need enough fuel on hand to sustain that outage, whatever that long period of time, right? The generator will continue to work so long as it operates and you are feeding it fuel. But when it run out of fuel, then the power stop. And if something fails on it, then the power stop. Okay, so those are some consideration. Also, with power protection, you have voltage regulator that you can add on this line, which are designed to maintain a consistent level of voltage. There's line conditioner that will improve the quality of electricity. Those are consideration as well in terms of deployment for your power protection. And then also you can install surge protector, right? Which are the stripes where you plug everything into, and it will prevent the device like computer or what have you from being impacted of surge, right? And increase in electricity to those devices. So those are some other consideration as well. Okay, now what about network communication? One of the things we can do to ensure that we have good quality of communication is the quality of service. This is network technology that works together to provide high priority communication on a limited capacity network. So if we start to lose power, if we start to increase latency, maybe some kind of service fail, maybe the rate fails and we start getting latency all over the network, QoS or quality of service can help us to shape the traffic and focus on what it is priority for our critical business function, right? So we can shape the traffic and identify it. So we can focus on things like throughput or bandwidth, latency, how much delay we are getting, jitter, whether we are getting a variance in latency, maybe we have server going up and down, and maybe our cluster kind of bouncing a little bit. Now we are having a little bit latency, then we are good. Then now it's more latency, so the QoS can help with that, and it can also help with errors. If we are having errors, it can help shape the traffic as well. So the network administrator and the network engineer will need to identify those certain type of traffic. They will have to tag it, give them a priority for bandwidth or the throughput, right? This is all for the quality of service implementation. Pretty much very network vendor, Cisco, Fortinet, Juniper, all of these different companies all support QoS, quality of service, built in to their operating system. So you can implement these on pretty much any network device, and actually some of them will do QoS automatically as well. So of course we need to identify the traffic, we need to classify the categories, that's traffic, and then we need to configure the network device to support that. So now sometime else that very important about your recovery strategy is to understand your devices. Certainly when it comes to your firewalls and your network devices, in a recovery, when a device fails and maybe it reboots, the one thing we do not want it to do is failover, which means it default to allowing all the access and all permission during a failure. So if a device fails and when it reboots, we do not want it to allow any access or to allow any permission. We want it to fail safe or fail secured, which means that it defaults to allowing nothing, no access, no permission, that we know that system is safe and we can now start troubleshooting where the failure happened. On the other hand, if an attacker discover that your devices are capable of failing open, then all they have to do is to deny the service, make it a reboot, and now it fails open and now they own the device, right? We don't want that to happen. So again, looking at everything collectively, we want everything to fail in a secure state. So if the firewall fails, we want it to fail in a closed state. We want it to fail and not allow access and not allow in any kind of communications. Same with the switch, same with the load balancer if it is possible. Okay, now all the load balancer will accept that, but definitely the switches and the firewalls will, right? Again, over here we have our storage. All again, over here we have our storage, we have our RAIDs, we have our RAID 0, 1, 5, 10, whatever we decide to use. We need to make sure that we have that built in so that we have redundancy for all of our strategies. And again, we have our load balancing, right, where you are coming off and load balancer, and maybe you have multiple net card on every server, right, that are all accepting different type of traffic. Then we balance those communication across the different servers. And then also you can see here that we have two switches, so that we have high availability built in. Same with the server, we have multiple servers so they can fail over, right? If one fails, it fails over. Pick up the work, so we continue of the business function. Pick up the work, so we continue our business function. And then if we have power outage of some kind, we have our UPS, our generator, depending on your tolerance level, right? Short term versus long term power outage, then we have those that will pick up and make sure that all of these devices maintain operational. So the bottom line for this video is know the different method of recovery that we're talking about here, know the different disaster recovery protection method, understand the quality of service, and know the different recovery states.